Hey, AP Bio students, it's SG. Sure, some of you are hard at work with wrapping up your report for the investigation on Mendelian genetics with corn. And I wanted to help you out just a little bit, as some of you are probably looking at results and wondering what the heck is going on. I'm only doing this video because some of my top students were having questions and conversations with me today, and they weren't sure if they were doing it right. And so I want to reassure you how to do this the right way in case you're like, what does this mean? Why am I getting these results? So let me show you some stuff here. First off, if you have not watched the AP Daily video on chi-square testing, please go do that for yourself. Beyond that, if it's still not making sense, this link here is in the slide deck folder of Unit 5. I suggest that you go through it, read it carefully as it walks you through step by step for setting up your hypotheses, ultimately to getting to a point where you calculate your chi-square value, you try to match it up to somewhere on a confidence interval, and then you get to a point where you either accept or reject the null hypothesis. So please use those resources if you are not understanding them. Some of you also might be looking at some of your results in part C of the lab, and you're not sure whether you're doing your calculations right or not. Well, I have a resource here that I'll share with you, and I'll send the link out for it momentarily. But let me show you this. This is from a college up in Napa. I think it's Palomar Community College. And they have this little automated chi-square dihybrid cross program here where you can plug some numbers in. And so as I had this student today after school showing me these numbers, they were wondering if they actually did the chi-square test or not the right way. And so I'm going to plug these numbers in. So they had 325 and 86 and 99 and 47 from their two parents who were heterozygous for the color and the texture trait. And so if I press calculate here, it spits out a bunch of numbers from total number to observed ratio. Notice that this is not exactly 9 to 3 to 3 to 1. It's a 6.9 to 1.8 to 2.1 to 1 ratio, as well as spitting out some expected values here as well. I talked to Mr. Bergman, our AP stats guy. He said that expected values should be left in a decimal form. In this automated version, though, it only gives you whole number form, rounded either up or down. In the AP Daily video, I believe they leave it as decimal form. I'm going to go with Mr. Bergman on this and say stick with rounding to decimal. Sorry, don't round, but keep it in decimal form. Okay. So for this individual and the results they got, this chi-squared value came out to be 7.93. When they did it in decimal form, it came out to 8.2, so not too much of a difference. But so then realizing that the degrees of freedom were 3 because you have 4 possible phenotypes, -1, they soon realized, like, well, wait a minute, my value fell somewhere in here. And so that value of 7.93 is somewhere between a probability of 1 to 5%. Doesn't that mean that I reject the null and accept the alternative hypothesis? It does mean that. Ideally, we would hope to see a value up here. That's ideal, but you did the science here. You did the steps. You did these counts. You took these steps to get to a statistical analysis of whether the data was significant or not. And right now, it's saying that something's going on. And so what does that actually mean? Well, this is another resource I want to point you to. I'll share this link here as well. And reasons for perhaps having the results you do might be due to a couple of different things. We looked at these corn thinking that perhaps their parents, or assuming that their parents were heterozygous for both those traits. And in reality, that might not have been the case. So that's one possibility for the error that we're seeing. Another possibility is that perhaps these two traits, the color trait and the texture trait, are due to some kind of linkage, gene linkage, or what we refer to as autosomal linkage. Something that we have not dived into yet, but I want to dive into with you tomorrow. But so these are possibilities for why you're getting the results that you're getting. So I'll point that out to you. I'll share these links with you so you can read a little bit more into it. Again, If you're not sure you're doing your math right, I might just plug your numbers into here. Do you get chi-squared values that are really, really close to what you're getting? If they're coming out to be really, really close, you're probably doing this right. Again, if you're getting a value that falls somewhere in here, don't freak out. It just means that, hey, there's something else going on here that we're probably just not considering, and you want to definitely discuss those in your conclusions. I'll leave you with this last statement. Science is not a linear path. It's not, again, just always arriving to this answer and being done. Science is a cycle. It leads to more questions, more investigations, repeating experiments, refining experiments. I just want to reiterate that as future scientist yourself, perhaps. Hope that helps. If you got questions, send me a message on Remind, and I'll do my best to address them sometime this evening. Bye.